So this is a demonstration of a technique that you can use to create a two-way constraint in Maya. So ordinarily, I'll create two new objects to show this off. An object can either be a parent, a child, or a sibling of another object. So here we have it being the child, or we can switch around that hierarchy. So this one is the parent, or they could be siblings where neither of them affects each other. Now, what if we wanted to be able to switch between this one being the parent and this one being the parent? So you might try creating a parent constraint from here to here. We're going to do buffer groups. So we'll go from p^1 to group 1, parent constraint, p^2 to group 2, and we immediately get a cycle. Even if we turn one of those parent constraints off, we still get cycles. And I explain that in the actual blog post. I'm not going to talk about it here because this video is more of showing it off inside of Maya. So this example uses a different technique. So right now, the purple one is the parent of the blue one, which in turn is a parent of the red one. And you can see that here, because the red cube's parent attribute is set to blue, and the blue cube's parent attribute is set to purple. I could change this to none, and now the purple one does not affect the blue one, but the blue one still affects the red one. So let's open up the node editor and we can take a look at how this actually works. So I'm going to be looking specifically at how the blue cube's parent is switched. But it's the same for all three cubes. So the first thing that we do is we create a node network that would work as a parent constraint between the purple cube and the blue cube. And we do that by having a composed matrix node, which in this case is just a identity matrix, and that is used as the offset for it. So if I wanted to offset the simulated parent constraint, we would do it with this node. Then I plug in the world matrix of the purple cube. So I multiply the offset by that, and then we multiply the resulting matrix by the parent inverse matrix of the blue cube. And I talk about it in an earlier post, but effectively what that does is it finds the world space for this object, and then it kind of divides that world space by the parent space of this object in order to give us the matrix that this object would need to have so that the parent matrix, this matrix times the parent matrix would equal this object's world matrix. You can go back to that post if you want to look at it in a little more detail and see it written out, because it is hard to explain verbally. So then we take the resulting matrix and we plug it into a choice node. We do the same thing we again create a node network, but this time it is the node network we would need if we wanted the red cube to be the parent of the blue cube. So we create that matrix and we plug it in as another choice on the choice node. And I also create another composed matrix node with no translates, rotates, and scale set to 1, and plug it in so that we can have a none option for the blue cube. So the blue cube would be parented to its just parent space. So then what we do is we plug in the parent attribute into the selector attribute of this choice node. And that way we can choose which one of these three matrices is plugged into this decomposed matrix node. So it could be the matrix that would constrain it to the red one, it could be the matrix that constrains it to the purple one, or it could be the matrix that just leaves it alone. It doesn't do anything to it. But then we take that matrix, we decompose it into translate, rotate, and scale attributes, and we plug them in to the translate, rotate, and scale attributes of the buffer group above the blue cube. So now you can see that in this case, the blue cube has no parent. Now we can give it the purple parent, and then we can give it the red parent. Now, you can still run into issues using this system. So here I have blue cube as a parent of the red cube, as a child of the red cube, and the purple cube is just in world space. And now I'm going to take the red cube and I'm going to make it a child of the blue cube. So the blue is a child of the red and the red is a child of the blue. And you can see that now we're getting a cycle warning. So this system is more robust than a parent constraint because you can get away with switching between two directions of constraining, so blue to red or red to blue, but the user could set it up in such a way that it creates a cycle.